So, my name is Harpreet Singh Virk. I am here to present my supplementary assessment presentation on research method and project design. Um, it was related to my topic was secure data analytics and AI integration for my IoT satellite data in smart farming. So, smart farming is something related to use of sensors and robots in the farms um, for enhancing for collecting of the data to enhance the quality and efficiency of the food or of the crops that we get from the farms. So my client name was Myroslovi Kosakviki, whose nickname was Myro. We used to call him Myro, and his company name is Labortronics. And my supervisor for 6991 was Dr. Mohammad Dabag. So here are the contents of my literature review. Here are the contents of my presentation. It was literature review, individual design approach, initial design approach, and the references. And the last word I used. So here I go with my literature review, the press presentation. So it was the first I studied about smart agriculture solution harnessing AI and IoT for my crop management. It had the study explores the use of IoT devices, cloud computing, artificial intelligence, uh, enhancing sustainable farming practices. The traditional practices we used to have the plowing and clothing and making uh, the crops. The initial practices, the traditional practices that are being used in smart farms. So it was generally involved some sensors and robotics used in the farms. It was the first time that it was being used, so it improved something like that was beneficial for the food efficiency and the quality that was being resulted after the study. So after that, I studied about AI, IoT, and robotics in smart farmings. What are their uses, how they are uses, and the current application, and what are their potentials, what we can get if we use AI and IoT and robotics in the smart farming. It was just a conference paper that I explored out through the Google, and it was regarding the use of advanced technology in smart farming, including sensor, robotics, and artificial intelligence. The main aim was to increase the efficiency of the crop that we are getting from the smart farms in the study. And thirdly, I studied about enhanced data transmission platforms in smart farming, the use of a different type of data transmission practices for the to never lose the data packet losses and the battery life. It was something related to the sending of the data on the computer systems and to the computer system to the satellite. So it was something there is a packet loss due to the battery life in the study of the research paper. And after that, I studied about a hybrid system. It was related to federated transfer learning and digital twin enhanced secure cooperative smart farming. The use of small length wires and the long length wires, memory techniques that being used in this, and it combined both of them to make a agricultural federated transfer learning. It was related to FTTL in short form throughout the paper. After that, I studied about smart farm monitoring through artificial intelligence for enhanced of harvesting and productivity. This conference paper explored the integration of sensors, actuator, Raspberry Pi database system, AI, and machine learning softwares in a central server for monitoring water flow in the fields. So it was related to the water fields flow in the system through the workstations out there. So the weather station used to for monitoring of the sensors and robots and different type of integrated systems were used with in relation to the computer being used by the Raspberry database system to enhance more productivity and more software can be installed on them. And lastly, there was a map whiteboard as a collaboration tool for smart farming advisory services. Map whiteboard concept aims to reduce the workforce usage by teaching tools to the farmers using GIS tools to understand EO sensor systems. The EO sensor systems are the system that we are being used in the smart farmings, like the robots and the sensor systems. How they are working, and if they need any maintenance kind of thing, that so the farmers can maintain them off. It was related to something like that. So this is my initial design approach that I had. It involved uh, in my design approach, there are five different parts, which include IoT devices, my IoT satellite, cloud servers, web interference, and smart farming users. So it is my five stages included a basic structure with the cloud servers in between and exchanging of the data through the satellite. Uh, So here we are going through the first stage. The IoT devices collect data from the different sensors and send those collected data to the MyIoT satellite. And coming out to the My Satellite, this job for MyIoT satellite is to transfer the data to the cloud server. Here, the MyIoT satellite transfer the data to the cloud servers, and the cloud servers then transfer the data to the web interference. Then through the web interference, this data is transferred to the smart user, like the farmers or the monitoring company that is being who is monitoring up the smart farmers to collect the data and make a beneficial information from that, to collect and make it information so that it can be beneficial for the farmers to take any action about that. So here are my this is something is the initial implementation stage that we had. These are the setups on one end, like on the my IoT satellite and the IoT satellite end, and these are the runlinc systems, the web interfaces that I was talking about earlier. So the figure one show above figure shows the my IoT satellite connection in initial at uh, implementation. At first we have to understand about the MyOT satellite connection. Above my picture shows the steps for the MyOT satellite connection. There are a few steps and implementation at the steps stage setup stage. It is just basic installation of the code and registration on the website. For the implementation, data should be gathered and sent it to satellite using the E32 microcontroller and MyOT dev kit that was being supplied um, by our supplier, the company, the electronics by Myro, what we can say at the and the it is just basic installation of the code and registration on the websites for the run leg. For the implementation, the data should be gathered and send it to satellite using it through my Deva kit that I told you. After that, from the MyOT Dev kit to the satellite to MyOT website device manager and the device manager to run like user, and lastly displayed for the IoT data from the satellite. For a runlink system, there here is the basic run code that we had. Runlink system is something a web interface where the data is collected through the server from the sensors and the robots. So when we talk about figure 2 and 3, the above snapshot shows the screenshot program to fetch up the data. Here is the figure 2 and 3, figure 2 and figure 3. So the above snapshot show the simple program to feed data, and this function are used to access new data from the servers and include it in the table in the HTML document. Here you can see the programming of the HTML documents out there in the runlink system. So whatever you want to change, like the web interference, the location or something, it can fetch the data according to the location through the satellite by by the means of the systems, by the means of by changing up the transforming systems out there, or the locations of the longitude or the longitude as well. The feature data function sends the data to a GRID request to specified URL. The STS, since the data cannot be downloaded directly at the application level, then this means the user have to use the external sources like the runlink and the system to gather up the data. So it is being used as a third party system so that we can gather up the data and according to the sensors that we have. The runlink system tests and receives the data BHP to retrieve the data. Once it receives the information, it compiles up into a JSON and then goes through the each data structure from where it was in. For each objective, it invokes create rows. Right, for the JavaScript, it's talking about it creates up the rows out there function to create a table. Uh, this table in the runlink system is being created through the JavaScript programming, which I did alongside with the Naveen in my group. It invokes a create row function to create a table row. This row got added to the table body element ID with ID table body. So table body. So it adds up the sensors out there on the port is a create table, is a row out there where is the number of sensors out there D2, D4, D5, D12. It's the sensors that are being used in the smart farming in the real time environment, and they are sending up the data through the satellite through through the cloud server. And with the ID table body, if an error would occur within the context of the request, it is caught and it detailed output to the console. If there is an error in the transmission, it generally disables it and send request to the cloud server, where cloud servers retrieves the data again from that sensor and send it back to the workstation. That's all I did. So these are the references at the last about were, about the literature review that I did. Thank you so much, guys.